The coolest STEM-related gift that my family received this Christmas are these scooter wheels, which were given to my 10-year-old by his grandmother. The way they demonstrate science is that when you spin the wheels, these little lights inside the wheels illuminate so that you get this display of rainbow colors. The coolest thing about these wheels is that they don't require an external power source. So you don't need any batteries. You don't have to buy any batteries. You don't have to throw away the dead batteries. There's no waste generated. So it's a completely sustainable power source. Inside the center of the wheel is a stationary magnet, or a magnet that doesn't move. And around that magnet in this center blue circle is a coil of wire, probably copper, that rotates when the wheel rotates. You'll see as I rotate the wheel, that inner blue part is rotating as well. So the metal wire is rotating around the stationary magnet. And as you know, a magnet has two sides, at two ends. It has a north end and a south end. There's very different forces at those two ends, very different magnetic forces. If you try to put two magnets together with their north-facing sides, trying to push those two north-facing sides together, you'll feel a repulsion or a push against the magnet so that it's hard to push them together. But if you flip one of these magnets over and now you're facing the south side of that magnet toward the north side of the other magnet, you'll actually feel a pull that pulls those two magnets together. So that's how you can sense just how different the magnetic force or the magnetic field is at either end of the magnet. So if you take a coil of wire and you rotate it around those two ends of the magnet, the wire itself is going to feel a very different magnetic force, either a push force or a pull force. Inside the wire are tiny little particles called electrons, and these electrons can move. In fact, moving electrons is what electricity is. It's just electrons moving through things. And so as you rotate the wire around the magnet, the electrons inside that wire are feeling that changing magnetic force as it goes from the north end of the magnet to the south end of the magnet. And this causes those electrons to move. Now, we also connect this coil of wire to a piece of wire that goes through the wheel and connects each one of these light bulbs, so that when the electrons move through the coil, they'll move out into the wheel through the light bulbs and then back into the coil of wire again. When the electrons pass through the light bulbs, they actually pass through a different kind of material that glows when it's hit by electrons, and that's what causes the light bulbs to turn on. So these wheels, each one of these wheels is its own little power source, and I think that's magical.